Hey, sorry I'm posting so late tonight. I just got home from the Fusion night, which was really fun. Ask someone about it who was involved in making it happen. It was pretty cool. So I'm not going to be able to do this the same justice that the computer animations can, because I think that actually getting to play around with the circle dissection tool and then watching the circle unpeeling tool is going to be better than my drawings, I promise. So I will also put the links to that in the description for the YouTube video. But we're talking about the area of circles, because now that we know how to describe the circumference, we can talk about the distance around. It's also important to be able to talk about what's inside that circle. When you get to the buildings that you're going to be proposing, you'll want to know, if you have a garden that you choose to make a circle, what's going to be the space that's available inside that garden. In order to get there, I want us to start by reminding ourselves how circumference works, just so that we've kind of got our tools. So we had from Tuesday that circumference is going to be the same as the diameter times pi. And let me just kind of draw my circle on the side. So you've got the radius, we've got the diameter, circumference is all the way around. And that puts it in terms of the diameter. But what if you wanted to have the circumference in terms of the radius? Well, we know that the diameter is twice the radius, because you have to do the radius and then the radius again to go all the way across the circle. So you could also write the circumference as 2 times the radius, because that's the diameter, times pi. That's a separate way that you could write the circumference. So I'm going to keep that up in the corner here, because we're going to come back to that. So we've got this circle, and you could take this circle and you could break it into 2 pieces, and that would give you the 2 halves. And if I unrolled that circle, I would end up with something that looks like this. Can't really do too much with that yet. But if I increase the number of cuts, maybe now I cut it into 4 pieces. If I were to unroll that, I would have 4 of these wedges going over. And if I kept doing that and increasing the number of cuts and increasing the number of cuts, so we can just kind of keep going and keep going and keep going, students found that you ended up, when you unrolled this circle, you take it and you just kind of roll it out, that you're going to end up with this row of all of these almost looking like triangles, but these very tiny wedges that are going to end up coming out from your circle. And so if you have it unrolled all the way out, this would be your circumference down here, because you've just unrolled it. And then you have, coming from the outside of your circle into where that point would be, that would be your radius. So if you take that, that doesn't look like something that we can find the area of yet. Not quite. But what if I doubled it? What if I just did this again, and I took a second circle and I unrolled that and I fit it in? Now you're going to have something that some people said looked kind of like teeth, but it looks a lot like either a parallelogram or a rectangle, depending on how many slices you've got. Now, a parallelogram or a rectangle, we do know how to find the area of, so this is useful. No matter what, whether it's a parallelogram or a rectangle, you can find the area of that figure by doing the base times the height. In this case, the area, or the base, is the circumference of the circle, and the height is the radius. So we have the area as the circumference times the height. Well, this is where this comes back into play, because, the circumference times the radius. Because I already have the radius here, I would like to put the circumference in terms of the radius so that everything on the left side has to do with the radius. That way I have fewer variables that I have to deal with. So if I look over here, I know that the circumference is equal to 2 times the radius times pi, so I'm going to just take that and replace that in where it was the circumference. So if I rewrote this equation, but now I've replaced c with 2r times pi, I'm going to have that the area is equal to 2 times r times pi times r. See anything that you can simplify there? Well, I have r times r. Any number times itself, you can write that as r squared. So 2 times pi times r squared is going to be the area of this doubled figure. But that's not my circle. This was 2 circles. So we could write this as the area of 2 circles is equal to 2 times pi times r squared. So if I wanted to find the area of just one circle, just like we did with the triangle, just like we did with a trapezoid, if you've doubled it, now to get back down to the one shape, you need to cut it in half. So the area of one circle, and I'm using this circle, that's not a 0 or an O, it's a circle, you could take the area of 2 circles and divide it by 2. Looking at that, I want to know, is there anything that I can simplify? Well, if I have 2 divided by 2, that's going to be the same as just having times 1. So I could say that the area of my circle is going to be pi times the radius squared. That is a formula I can work with. All I need to know is my radius in order to find the area. And if I know my diameter, I know how to find my radius. I just cut my diameter in half. If I know my circumference, I know how to find my radius. You could find the diameter and then find the radius, or you could use this equation and get the radius directly. So now, as long as I have any information about the lengths inside my circle, I'm going to be able to find the area. So that was this dissection method where we doubled. There's another really cool method that I had never seen before this year, actually, where they unpeeled it and they turned it into a triangle. And I'm not going to even try to show that here. I have that in the description, so you should check that out. So we want to apply this. We have a formula. Let's show how that works with numbers. So on your blueprint, you had this slices of pizza, right? We had, I think, 4 slices of pizza. And we knew that a slice was 7 inches long. And I asked you how many square inches would be in the entire pizza. I put a clue word in there, square inches. If you're talking about anything in terms of squares, you're talking about area. So I know I need to find the area of this pizza. So first thing I'm going to do, I'm going to just put in that I need to find area, and I know that that's going to be pi times r squared. Always start with the equation, because then you know what you're going to be doing. You've got it there for yourself. That's one of your tools. So now I look over at what I know. I know my radius, because we're going from the center to the outside of the circle. So I can replace, in my equation, the radius with 7. A equals pi times 7 squared. Looking at that, I know that 7 squared is going to be 49. So I have pi times 49, which would be an exact answer. But if I wanted to approximate, since pi times 49 doesn't really feel like I know exactly how much that would be yet, I could say that's approximately equal to 3.14 times 49. And, let's see, 49 is about 50. This is about 3. So I feel like I'm going to be in the 150 zone. I think it was 153 and some change, approximately, square inches. So we're in that zone. And since I'm approximating 3.14, you should never be going past the hundredths place anyway, because we cut it off at that point. So you could stay exact, you could also go approximate. We are going to use this when we compare areas of polygons to areas of circles in order to think about what's actually going to be the best type of building to offer your client. So once again, I'd say go back, play around with that circle tool if you want to remind yourself, get a deeper understanding of how you can derive or come up with the area of a circle, and then also check out that peeling animation just because I thought it was really cool. I geeked out about it when I found it. Have a good night. I will see you very soon.